So let's start. Last week I was trying to refactor the object context locking with log primitive offered a helper offered by SeaStor. I'm putting the my draft PR, the URL to my draft PR in the chat window, so it could have some preliminary reviews, and also created some clean up PRs. And that's me, Chumei.
These days I'm considering the collection implementation and draft the design, and I also saw some comments from Sam for the OMAP tree, and I'm going to update the patch recently. That's all.
Chumei, I missed you the first words. What do you mean by
collection implementation?
Okay, collection. Oh, thank you. Gotcha. Ritek.
Hello. This week I'm back from my PTO. I got back to Crimson and reviewed a bunch of PRs, particularly the Szechuan's Crimson Interruptible library. Posted review there. That's me.
Ronan.
Hi. I've finished answering all comments on the classic scrubbing. We'll create a squashed squash branch with the changes, ready for merging. Other than that, I'm looking at CBT for Crimson. That's it for me.
But Ronan, regarding your PR, I think it's still need to squash the related commit into a single one, so it could to ensure that every commit is atomic, so it can be better reviewed before get merged.
Yeah, what I'm going to do, like I said, is create a new stream and just try to divide all the changes into some logical parts. And then very few, not the 20 commits I have now, but a few logical parts, and then try to push this PR for review, this stream for review. That's the idea.
Just try to structure it however you think will be most readable and comprehensible to your readers.
That's the idea. I try to do that.
Sam?
Yep. See. I'm making a bunch of changes to the internals of journal because running it on an actual disk revealed that it has a tendency to pick up segments from the last time I ran it and think they are part of this run's journal. So I added a nonce based on a UUID, which entailed a few changes to the UUID header in Ceph. I am now, while I'm at it, I'm fixing, or I'm implementing checksums in the journal, so for real actual atomicity. They were almost implemented before, but I didn't actually do the checksumming and rereading. It's a little bit more complicated than I thought because there are at least two ways we scan segments where we really don't want the overhead of computing checksums. So I'm going to have to add a little bit to the journal segment rollover mechanism to write down the length of the segment so that if we get a cleanly closed segment, we don't have to incur the overhead of recomputing all the checksums. So that's what I'm working on now. The piece after that will be fixing concurrency so that I can get decent performance numbers. But I think I'm probably going to push a PR for what I've got now, plus the checksumming before next Tuesday, or maybe immediately after, and then work on the next pieces separately. The thing that does checksumming works now, and the numbers are okay. We get like 4,000 synchronous IOPS, but that's completely single-threaded. A full I/O has to complete between each one, with no optimizations whatsoever for batching commits. Once we can keep more than one operation in flight at a time, I expect a good factor of 10 improvement there, probably more. And then we'll get down to the real hard work of separating longer-lived blocks into separate segments and other optimizations of that nature. So it's a good start. I also did some reviews of Chunmei's OMAP tree thing. I'll take another look once those are addressed. And I looked over Yingzhen's plans for a transaction manager that integrates support for persistent memory and also block-based Optane. I think that plan is shaping up to be appropriate, so I'm looking forward to do further work there. I'm off Wednesday, Thursday, and Friday of this week, but I'll try to keep an eye on email. That's it.
I got a question, couple questions regarding to your UID and the concurrency. What do you, how is the UID involved in your change in SeaStor? SeaStor, sorry.
BlueStor, FileStor, every store we've ever had generates a random UUID when it runs makefs.
Oh, okay, I see.
That's literally all I'm talking about. It then uses that number to derive a per segment nonce that it then writes into each record. So that when we reuse a segment, when we let's say a segment is 8 gigabytes long, and the first time we use it, we write the full 8 gigabytes. But the second time we use it, we write about 4 gigabytes, and then the OSD turns off and turns back on. When we go to replay that segment, it's really important that we get to the end of that 4 gigabytes and stop reading. We need to know that the next entry after that belonged to an older version of the segment. That we already garbage collected and released. It's so that the block implementation underlying it doesn't need to incur the cost of zeroing out segments when we release them, which we'd have to do otherwise.
And how? What do you mean by concurrency in this context?
Transaction Manager is designed to detect and flag racing commits. When two commits try to write to the same block at the same time, not in different threads, by the way. These all have asynchronous operations. So any particular write will do a sequence of reads and writes. In between, the reactor may do other things, like, for instance, do a different sequence of reads and writes on behalf of another transaction. This is completely harmless unless they try to read and write the same pages. We talked about this in some detail with the original design, as it's how databases typically work. All of that code exists, but I have no confidence whatsoever that it works. So once I run FIO with more than one outstanding IO at a time, I expect crashes and bugs. So I expect to spend some time fixing that. That is all.
Okay.
It's important for, performance, though. We need to be able to service, let's say the client has 16 writes outstanding, because it's a fairly deeply pipelined workload, and benchmarks often work that way. Then we should be able to be servicing all 16 at the same time, sort of, resources permitting. Quite separately from this, later on, we will have different threads writing to entirely separate sections of the disk. But that's later work. Okay. This is concurrency, not parallelism. Let me put it that way.
Sure. Okay.
It's no different from in BlueStor how we can commit many transactions at once. If all of the transactions arrive at the queue while it's committing the previous batch, it will batch the new large set of transactions and send them all down at once. Because the client didn't wait for a transaction 1 before sending transaction 2. It sent 16 out at the same time. So there are a lot of opportunities for batching and combining by permitting us to do that. And I've done relatively little of the optimization around that. But with the new driver, with the new performance driver, I should be able to. What's that?
Can you use the executing stage for batching the write to the?
No, I explicitly don't want to do that. The executing stage would serialize them. I don't want to do that. In most cases, these writes will be non-conflicting. And so it doesn't matter what order they execute in. They'll be correct either way. Transaction manager is designed so that if they do conflict, the second transaction will fail and will have to be retried, which is fine.
Okay.
If I used executing stages, I could never get concurrency, right? Or I'd have to design it really carefully and detect the conflicts up front.
Yes, it does not buy us some advantage if you use execution stage for this purpose.
That's useful when we explicitly want to. And keep in mind, in the OSD, we don't use one executing stage. We use n of them, one for each PG. That's why it's okay. We deal with concurrency by permitting multiple PGs to operate concurrently. It's only on any particular replacement group that we serialize operations. That's the entire point. That's why it's analogous to the PG granularity lock in classic OSD.
Xuehan.
Last week, I spent a lot of time doing some temporary job in my office, so I didn't make much progress. But from yesterday, I'm back on track. I think this week I will first try to tackle the issue that I mentioned by Radic in the interruptible future PR, and after that, I think I will continue debugging the client to request sequencer, which is supposed to preserve the client request order in case of OSD map change or peering. That's all for me.
Sean, I don't quite get how is the client sequencer getting involved in your recovery? What do you mean by client resequencer? Does this part reside in librettos?
Oh no, the client request sequencer is the stuff that I added to Crimson, which is supposed to preserve order when there is a peering event. Preserve the order of client requests. It's just meant to resolve the issue that we discussed the other day, that which at the time we supposed to we intend to resolve the order problem in the OBC lock layer.
Okay, probably I could ping you for more details offline.
Okay.
I'm kind of interested in this part, but I don't quite get what you mean. Yingxin?
Last week I sent out the documentation about the SeaStor with multiple tier devices, and I'm still refining the documentation and address the comments, mostly about the atomic guarantee and architecture, possible architecture changes. And that's all. I will take annual leave next week.
Enjoy your time. So you won't be able to make the next stand-up, right? Is that what I mean?
Yeah, I think so.
Okay. By the way, did you... Please go on, sorry.
Next week, I assume I should read the review the FL tree. Is it ready?
Yeah, it's insert is ready. Insert and split is ready.
So is it in a state? Okay, I'll take a look at it next week. I'll put it on my list.
Okay, thank you.
By the way, I also uploaded the log for the messenger test failure. Probably could take a look at it at your convenience.
Okay, I will.
Thank you. Anything else? Nope. Okay, have a good one. Talk to you later. Thank you.
Thank you. See you soon.
See you.
See you soon.
See you.
Bye-bye.
Bye.
Bye.